In today's video, we'll be looking at how you can use ServerStack OrmLite to bulk insert large amounts of data quickly and efficiently. We will look at some benchmarks for multiple database systems like Postgres, MySQL, MS SQL Server, and SQLite with multiple different bulk insert methods so you can choose the right approach for your system. The bulk insert API is very similar to that of normal insert all methods using OrmLite. It takes your typed data, but it also takes a bulk insert config options. The OrmLite bulk insert API encapsulates these RDBMS differences in implementation to let you take advantage of the fastest way for each platform to insert a large quantity of data. For example, Postgres uses a binary copy command from a standard in via npgsql, whereas MySQL has a MySQL bulk loader, which actually uses a local temporary file. You can avoid this local temporary file for MySQL by using the MySQL connector, which uses an in-memory stream. And then MS SQL Server has SQL bulk copy, which imports data written to an in-memory data table. This enables you to pick the right technology for your use case by also being able to switch to a SQL multi-row insert mode for each database if your database environment has limitations preventing you from using the native optimized bulk insert. We can use this on the bulk insert config object specifying the mode as SQL. On the same bulk insert config object, we can also control batch size for each job, enabling you to further optimize based on your specific use case. To give you a better idea of the performance of OrmLite's bulk insert feature, we have a series of benchmarks that compares single row inserts, SQL multi-row inserts, and the optimized native implementation to show you the potential speed increases from each option. We did this testing across different CPU architectures such as ARM using an M2 MacBook Air and two x86 platforms using GitHub Actions as an Ubuntu 2204 Docker image for one and a native Windows Intel platform for another. We did this to see how much of a difference we see across relative performance within an architecture for each database vendor as well as relative performance for different methods of bulk loading. Jumping into the benchmark results, we first did our tests on an Apple M2 MacBook Air with 24GB of integrated memory. Our tests encompassed multiple database systems like SQLite, PostgreSQL, MySQL, and MS SQL Server. Each test involved inserting different quantities of rows ranging from 1,000 rows to 1,000,000 rows at a time. When comparing the results for the M2 platform against each vendor's natively optimized bulk insert method, the PostgreSQL's binary copy stood out as the fastest bulk insert implementation. For instance, when inserting 1,000,000 rows, PostgreSQL completed the task in under a second, which was significantly faster compared to other database systems on the M2 platform. On the other hand, MS SQL Server was significantly impacted by the overhead of running AMD 64 Docker images on an ARM platform, leading to much slower performance. In the same 1,000,000 rows insertion test, SQL Server took considerably longer with a mean time of around 8.5 seconds. Next, we switch from testing the optimized bulk insert method for each database vendor to what's called multi-insert rows syntax, or in the bulk insert config, the SQL mode. Under the hood, this uses a more plain SQL way of performing bulk inserts, meaning it will also work more consistently regardless of your specific database environment. Now that all the different database vendors are more on an even playing field, we see SQLite memory and SQLite disk pull ahead of the other vendors. But for the distributed databases, Postgres here is still an amazing performer. MySQL and MySQL connector aren't that far behind, but MS SQL is still significantly slower than all the other vendors. Again, this is most likely because we don't have an ARM optimized method of running MS SQL Server using Docker. And finally, if we do the comparison of single row inserts, that is the normal way you insert data, versus multi-row inserts and bulk inserts, we can see we get a massive speed up from each and every vendor, where you can expect an improvement somewhere around 50 to 100 times faster. And for the larger workloads, we still see a big improvement even when comparing multi-row inserts or the bulk insert SQL mode versus the optimized method for each database vendor. We can see differences here between 2 and 10 times, where MS SQL Server sees the biggest improvement on the ARM platform. For the more traditional setup of Linux on an x86 based system, with the exception of a MySQL outlier, all the native optimized methods for bulk insert perform well, and the MS SQL Server performance has improved a lot, though it does scale the worst as the amount of data increases. If we then switch to SQL mode of bulk insert via configuration, MS SQL Server again takes a massive hit in performance, while the other platforms show relatively consistent performance. It's not clear here if the SQL Server's poor performance is due to having a suboptimal Linux port or running from a Docker container, or perhaps a memory limitation with GitHub Actions having only 7 GB of RAM. Either way, if you're running Microsoft SQL Server on Linux, you may want to consider running your own load tests to check you're not getting poor performance in your environment, and whether or not you'd be better off running SQL Server on a Windows instance. Switching to Windows to give MS SQL Server the best fighting chance, we still see PostgreSQL continue to take the bulk insert performance crown, but the gap has significantly reduced. All in all, regardless of your platform or architecture, the OrmLite bulk insert feature makes it far more accessible to do your own testing and more easily improve your system's performance when it comes to ingesting large quantities of data into your SQL database. You can configure the way your bulk inserts work with minimal changes to your code, so if you are currently using the insert all methods in your server stack application codebase, consider switching to bulk inserts and giving it a try. It's available from Server Stack 6.10 onwards. If you have any feedback with your experience with OrmLite or bulk inserts, let us know in the comments or join us in our GitHub discussions or Discord. ServerStack is free for open source or individuals, so anyone is welcome. And as always, thanks for watching.